This video is to show how to create this hexagonal toy. You can make different shapes like square, round shape, star or any other shape you want. The approach is the same. I have prepared the video in different languages. Please follow the link in the description below if you want to watch the video in your preferred language. Let me move on. Create a new file. In the Part Design Workbench, create a new body. Rename it as Hexagon Part. Create a new sketch. Select XY plane. Use the polyline to draw the shape. The dimension and angle depend on what you want to create. The key dimensions are inside space and the gap, which I will explain the details later. Select these lines and apply parallel. Same for these two lines. Select these 2 points and the x-axis and apply symmetric. Select these 2 points and define the horizontal distance as 6 mm. Define this line as 2 mm. Define the angle as 110 degrees. Define the vertical distance of this point to the origin as 3 mm. The sketch is fully constrained. Check the horizontal distance of these points, click Reference. It is 2.1 mm and we'll explain this one later. Close the sketch. Select the sketch and use Pad tool. Click Symmetric to Plane. Length is 150 mm. Click OK. Create a new sketch. Select XY plane. Use Line tool to draw a horizontal line from the origin. Set the length as 57 mm. We'll show the purpose of this line later. Switch to Draft Workbench. Select the pad and hold the Control key, then select the sketch. Or I can select the pad and hold the Control key, then select the line. It is same. Select Path Array. Change Count to 20. With 20 pieces over 57 mm, I can calculate the gap between each piece. Or I can check it by TechDraw. Switch to TechDraw Workbench. From TechDraw, Page, insert Default Page. Go to Page, change the scale to 3 to make it bigger. Select Path Array. From TechDraw, TechDraw Views, insert View. Click the upward arrow to change the direction. Click OK. Select these 2 points and check the distance. It is 2.1 mm, which I show in the sketch before. I call it as inside space for now. Select these 2 points and mark the horizontal distance. It is the gap between 2 pieces. It is 1 mm. Select these 2 points and mark the horizontal distance. It is 57 mm, that is the horizontal line in the sketch. This is the key dimension. If the gap is too big, the large hexagon cannot hold the small hexagon. Just like this. They all are individual pieces not linked together. At the bottom, go back to the 3D file. The gap must be smaller than the inside space. If I use gap as half of the inside space, it is safe. But it also depends on the shape and the angle to create the V-shape piece. So, you can design the shape and size like square, round or star provided the inner piece doesn't come out. I make a mini model to test before I create the final one. As I don't want to spend 3 hours to print, and the model doesn't work. Switch to Part Design Workbench. Create a new body, name it as Triangle. Press the space bar to hide or show the object. In this case, I will show the path array for now. Select the body triangle, create a new sketch. Select the XZ plane. Use polyline to draw the shape. Select these 2 points and the x-axis. Then apply symmetric. Select the angle dimensioning tool. Define the angle as 60 degrees, as I will repeat the pattern 6 times to make the whole piece. Select Dimension tool. Define the length as 90 mm. Define this one as 90 mm too, so it is long enough to cut the V-shaped piece. Set these 2 lines as 50 mm long. Close the sketch. Apply Pad tool. Click Symmetric to Plane. Use the default 10 mm which covers all the V-shaped strips. Click OK. Switch to Part Workbench. Select the path array, hold the Control key and select the triangle. Cut the path array by the triangle. Switch to Draft Workbench. Select Cut and apply Polar Array. Change X and Y to 0. Change number of elements to 6. Click OK. The axis is not correct. Go to Path Array. Change Y-axis to 1, and Z-axis to 0. Expand the array and select Cut. Go to View and change Transparency to 80. You can see individual hexagonal piece. Select Array. Go to File, Export. Select the STL as the file type. Save. Open the STL file just exported. This file is ready for 3D printing now. As I use Bamboo Lab 3D printer, so open Bamboo Lab Studio to import the file. Rotate X by 90 degrees. Slice it. It will take 2 hours and 19 minutes to print. Just send the file to the printer to print. It is finished. If you find this video interesting, please subscribe and give it a like. Thank you for watching.